Hey everyone, and welcome back to the channel. Today, we're diving into a truly epic topic. One that involves colossal forces, breathtaking landscapes, and a history etched in stone. Glaciers. These icy giants are far more than just frozen water. They're nature's ultimate sculptors, shaping our planet in ways you might not even realize. So, buckle up, because we're about to embark on a chilling journey to understand how glaciers form, flow, and transform the very ground beneath our feet. Let's start at the beginning. How does a glacier even come to be? It all begins with snow. Lots and lots of snow that falls in areas where temperatures stay cold enough for it to accumulate year after year. As new snow falls, it compacts the older layers beneath it. This compaction, combined with cycles of melting and refreezing, gradually transforms the fluffy snowflakes into granular ice called firn, and eventually into dense, solid glacial ice. Think of it like making a giant, incredibly slow-motion snowball over centuries. Once enough ice accumulates, gravity takes over. Glaciers aren't static. They actually flow, albeit incredibly slowly. This movement happens in a couple of ways. The ice itself can deform and slide internally, especially in its lower layers where pressure is immense. And if the glacier sits on a slick bed of meltwater, it can even slide along its base, sometimes moving surprisingly quickly for an ice behemoth. This constant, relentless motion is what gives glaciers their incredible power. Now, let's talk about the masterpieces these icy artists create. Valleys. As glaciers flow, they carve out distinct shapes. Unlike rivers that create V-shaped valleys, glaciers sculpt iconic U-shaped valleys, sometimes called glacial troughs. Imagine a giant scoop relentlessly scraping through the landscape. This U-shape is a telltale sign that a glacier once passed through. How do they do it? Glaciers employ two primary tools for erosion: plucking and abrasion. Plucking happens when meltwater seeps into cracks in the bedrock beneath the glacier, freezes, and expands, literally prying off chunks of rock. The glacier then carries these fragments away. Abrasion, on the other hand, is like sandpaper on a colossal scale. As the glacier moves, the rocks embedded within its base and sides grind against the bedrock, polishing and scoring it. This process leaves behind characteristic scratch marks called striations, which show us the direction the ancient ice once moved. It's pretty amazing to think about. Beyond U-shaped valleys, glaciers create a whole suite of dramatic landforms. Picture this: a glacier sitting in a bowl-shaped depression on a mountainside. This depression is called a cirque. They're often steep-sided and have a characteristic armchair-like shape. When two cirques form back-to-back or side-by-side, their eroding walls can meet, creating a sharp, jagged ridge called an arête. If three or more cirques erode a mountain from different sides, they can leave behind a towering, pyramid-shaped peak known as a glacial horn. Think of the Matterhorn in the Alps as a perfect example. These features truly showcase the raw power of ice. But glaciers don't just take, they also give back. As they move, they pick up and transport vast amounts of sediment, from fine silt to massive boulders. When the glacier melts and retreats, it deposits all this material, leaving behind a unique geological fingerprint. These deposits are called glacial drift. One of the most common depositional features are moraines. These are ridges of tilled unsorted glacial sediment that accumulate at the edges or terminus of a glacier. We have lateral moraines along the sides, medial moraines, where two glaciers merge, and terminal moraines, marking the furthest extent of a glacier's advance. Drumlins are another fascinating feature. Elongated, oval-shaped hills of glacial till that are often found in groups, resembling a basket of eggs from above. They show us the direction of ice flow, with the blunt end facing up glacier, and the tapered end pointing down glacier. And then there are eskers, long, winding ridges of sand and gravel. These are actually the fossilized beds of rivers that flowed underneath the glacier, carrying sediment in ice tunnels. It's like a secret underground plumbing system. Each of these deposits tells a story of the ice's journey and retreat. These incredible geological processes have sculpted some of the most iconic landscapes on Earth. Let's look at a few case studies. Think about the stunning fjords of Norway, New Zealand, or Alaska. These are classic examples of glacial troughs that have been flooded by the sea after the glaciers retreated. The deep, steep-sided inlets are a direct result of immense glacial erosion, creating breathtaking coastal scenery. Right here in North America, the Great Lakes Basin is another monumental testament to glacial power. These massive freshwater lakes were carved out and deepened by colossal continental ice sheets during the last ice age. The sheer scale of the ice needed to create such vast depressions is almost incomprehensible. And of course, the dramatic, rugged beauty of the European Alps, with their jagged peaks, U-shaped valleys, and countless cirques and arates, is a textbook example of alpine glaciation. Every turn reveals a landscape profoundly shaped by ancient ice. These places are living museums of glacial activity. The legacy of glaciers extends far beyond just pretty landscapes. For one, glacial till makes up some of the most fertile agricultural soils in the world, particularly in parts of the Midwestern United States and Europe. The grinding action of glaciers pulverizes rocks, releasing vital nutrients that enrich the soil. Furthermore, glaciers and ice sheets are enormous reservoirs of fresh water. When they melt, they feed rivers and replenish aquifers, providing essential water resources for millions of people worldwide. This freshwater source is critical, especially in arid regions fed by mountain glaciers. However, glaciers also pose hazards. Rapid melting can cause glacial lake outburst floods, where natural ice or moraine dams holding back meltwater suddenly fail, unleashing torrents of water and debris downstream. Calving icebergs from tidewater glaciers can be dangerous for shipping, and receding glaciers can destabilize mountain slopes, leading to landslides. Perhaps most critically, glaciers are powerful indicators of climate change. Their retreat and thinning globally provide undeniable evidence of a warming planet. Scientists meticulously monitor glaciers because they act like thermometers, reflecting global temperature trends. Studying them helps us understand our past climate and predict future changes, which is vital for our planet. So, what can we do with all this knowledge? Next time you're hiking in a mountainous region or exploring a coastal area, keep an eye out for these glacial features. Can you spot a U-shaped valley, a cirque, or even glacial striations on exposed rock? It's like finding clues from a geological detective story. And beyond appreciating their beauty, understanding the importance of glaciers reminds us of the delicate balance of our planet's climate systems and the need to protect our modern ice. They are truly vital to Earth's health. Thank you so much for joining me on this incredible journey into the world of glaciers. If you found this video fascinating, please give it a big thumbs up, share it with your friends, and don't forget to subscribe for more deep dives into the wonders of our natural world. Your support really helps the channel grow, and I love reading your comments and questions below. Until next time, keep exploring.